Hi, my name is Aman Yadav, and the purpose of this recording is to give a demo of the project that we worked on in the class of pattern recognition. So let's get started. The project I'm working on is called credit card fraud detection. So as we know that payment card industry has grown significantly over the last few years. Every company, institution, they're moving their entire business toward online services or e-commerce. This gives a client definitely a great convenience. So it has this is a major step toward the efficiency, accessibility, and profitability. But this comes with risks. Since not the buyer or the seller has to be present at the time of transaction, there is no way to verify the owner of the credit card. So this has given a great opportunity to the frauds or the cheaters. As you can see, in 2009, total 8.6 billion worth of dollars were caused because of frauds. So definitely that created a lot of loss to the banks. So what is the presented solution for this is that we want to create a fraud filter that would be able to predict the fraud transactions, and this filter need to be very efficient, practical, accurate, and really fast. This is the only way we can stop this frauds from happening. Okay, so now about the dataset. The dataset I worked on was taken from Kagel's website, which is open source. This dataset contains the real information or the transaction that was made by credit cards. This feature has a class that represents two values, one for frauds and zero for legal transactions. And the column name of this data was pre-transformed for security reasons. Now, the data or the this data set, credit card data set, is highly biased. Highly biased. What I mean by that is number of front transactions are very less than comparing to the normal transactions. So we need techniques to handle this biased data. So we have overall three techniques that we can use. First is undersampling, oversampling, and hybrid sampling. In undersampling, what we do is we delete the data of the majority class so that we can equalize the fraud and legal transactions. But in order to do that, we might also lose some useful information about the dataset. Oversampling is what we do is we repeat the fraud data, so so that we can equalize the number of fraud and legal transactions. Hybrid sampling is pretty much the combination of undersampling and oversampling. So the models I created is a neural network and random forest classifier. So at the end of this demo, we are going to compare the results of these two models. So neural network is pretty much how human brain works. So in networks, we have a large number of interconnected processing units, which is called artificial neurons. And these neurons are capable, or sorry, this neural network is capable of recognizing and predict the future patterns based on what it has learned from its training. This model is highly used for classification problems because it's very efficient in that area. A neural network can be classified into three major parts: input layer, output layer, and hidden layer. We have two type of neural networks based on the output layer. So if we have one neuron unit in the output layer, it is called binary classification. If we have multiple units, in this case, let's say in this case it's four, then it is called multi-classification neural networks. Since we only have fraud or legal, it means 0 or 1. So we will be using binary classification neural networks. Now, unit. So we have on a unit, the node has a bias and the edges represent the weights. So what we do to calculate the weighted sum, we multiply the weights and the input variables and take the summation of that and add it with bias. So we get the weighted sum. Now this weighted sum is passed to the activation function. In this case, I'm using sigmoid. And then this activation function gives us the output. This is the formula of the cost function that use in neural networks. So, the training of the neural network is done in two steps. First is forward propagation, and the second is backward propagation. In forward propagation, we calculate the output of the each node, and we do this layer by layer. And when the output of all the units of output layer is calculated, we calculate the error function, or we calculate the error using this misclassification error formula. Our target is to minimize this error cost, or minimize the error, and we can say we want to minimize the cost function. So in order to do that, we do the backward propagation. So once we have done calculate the error, we move from output layer to hidden layers in backward direction. So when we are doing that, we readjust the weight of the edges so that the cost function we have can be minimized. So this is basically over if we say on high level, this is what we do in backward propagation. Okay, so steps that we are following in this model is that first we do the pre-processing of data. Pre-processing, since this data set or Kaggle data set is already pre-processed, we don't need to do that. Data set sampling that I already explained, we can do using oversampling or undersampling. In this, we are in both models. I'm using oversampling. After that, we split the database. So we split the data set into two parts. We call it training set and test data set. So we are train our network on the training set, and then at the end we test our model to find the accuracy on the test data set. So after doing the splitting, we do the feature scaling. Feature scaling is pretty much to standardize the features that we have in our data set. Well, once that is done, we train the neural network, and at the end we test the model. So let's see the code for it. Yeah. So here, first you can see here that I'm splitting the data into 80 to 20. So this is the pretty much the code for to do that, to split the data, and then I have the train data and the test data. When I'm done with the splitting, I am doing data sampling. So since I know the number of fraud transactions are very less, so I'm trying to increase the number of frauds in the data set. Now that is okay. After that, I'm doing the feature scaling. So you can see that we do the feature scaling for each feature by calculating the mean and dividing by the standard deviation. And this is the code for my hidden layers. So I have 4 hidden layers, and I'm using sigmoid function as the activation function. And see here we can see we multiply the input variables with the weights, and then we plus the biases. Uh, and this is the input for the sigmoid function, and this is the output for each layer. And we do that, and this is our output layer. Once that is done, now I'm basically I'm taking the data in batch of 2048, which is here somewhere. Yeah, this is here. So because we cannot take all the data, because there are a lot of records um, in one chance, so we need to take it step by step. So we are creating batches, and then we run the session. So this is pretty much we do to train, and then at the end we are testing the dataset. Okay, so the accuracy that was given by this model is that 82.93% of the fraud transactions were detected correctly, but 0.10% of the normal transactions were detected as fraud. So it's not pretty much high, but still, if the number of normal transactions keep increasing, this percentage can also increase. So it is a good. Uh, so yeah, and the accuracy of the fraud transactions is okay, I guess. Um, now the second model that I'm working on is random forest classifier. So to understand that, we need to understand what is decision trees. So decision trees is pretty much similar as what we have in the data structures. So we have non-leaf node. So on each non-leaf node corresponds to one input variable or one feature, we can say. Edges represent outcome. So in this, outcome can be yes or no, and the leaf node is the terminal node which predict the outcome. So here the outcome can be male or female. So, yeah. So we have two type of decision trees: the classification tree and the regression tree. Regression tree we use when the output is a real number. So since in our case it can either be fraud or legal transactions, we are using classification tree in our random forest classifier. Okay, now cost. So the cost for the decision tree is measured by the homogeneity of the sample. So if I have all the data of one class, let's say fraud, then the homogeneity will be zero, and the cost will be zero, and which is our target to minimize the cost as much as possible. And this is a formula to calculate it. Now, random forest classifier. A random forest classifier. It's like the word suggests forest, so it's a collection of trees. It is similar to bagging, and I will explain in a little bit why. To create a random forest, we are using Bremen's algorithm. Yeah. Now, the algorithm for creating random forest is that let's say I have a data set of D. So I divide or I create B subsets of this data sets. So like D1 to DB are the subsets, and each one has a length of M. So by M, I mean length. I mean that each subset has M data instances that we pick randomly. So when we are splitting the node, so what we do is we choose the subset of the features that we have, and let's say of size n. We can choose any number we want. So between the features available that we have, we choose a random subset of the features, and we consider the splitting the node only on these features. The reason that we are doing so much randomization, because decision trees are has very high variance, so it's very much dependent on the training that data we have. So let's say I change my training data a little bit, then the decision tree will also change. So we want to do the loose coupling, and to do that we are doing this randomization. So outcome of the random forest is that since we have B subsets, so we are creating B trees. So we run our input on these B trees, and once we get the output, for classification tree we take the majority vote, and if it's a regression trees we take the average of the output. So this is how we calculate output in in random forest classifier. The steps for the random forest classifier are pretty much same that we had in neural networks. This is like the format how we train the networks, pretty much. So let's see the code for a new random forest classifiers. Okay, so here I'm splitting the test data, and here I'm oversampling the test data because I want to copy the fraud data to equalize the number of normal transaction and fraud transactions. Here I'm doing the feature sampling. Once I do that, I have this. This is where I'm training and testing my data. So this is the line that pretty much does everything for us. It create the forest, and here we test it on our test data, and here we get the prediction, and here is the classification report that we get. Now the accuracy of this model was that 93% of the time the fraud transactions were predicted correctly, and recall represent that 77.77% of the time all the transactions were in all the transactions, including the normal and fraud, 77.7% of the transactions were predicted correctly. So conclusion is that accuracy, in sense, if we are saying that number of fraud transactions that were detected correctly was high in case of random forest classifier, but the overall accuracy of, or we can say the recall, uh, was high in neural network. So it's kind of trade-off in both these approaches. Um, since we were given the data set that was pre-transformed, if it was not the higher accuracy we could have achieved, because if we know the real name of the column values of the features, we have a better perspective of the data set, and we can train our or we can create our model based on that, and it can give us better accuracy. um, Data, since we know that data set that was highly biased, so to create a model that is very accurate, or let's say very high efficiency, is a little hard. To increase the accuracy of our models, we need more data so that we can train our models on um, more data set, or multiple data set, and then I think it should we should be able to increase its efficiency. So well, this is the end. So thank you for watching, and good day.